Section 5.6, linear inequalities in two variables. We're going to start with a vocabulary term, and that term is solution. A solution is simply an ordered pair, x comma y, that makes an inequality true. That should be makes. So the first set of examples here, tell whether the ordered pair is a solution of the given inequality. Well, we'll be given an inequality like 3x minus y is less than 2. We'll also be given an ordered pair like negative 2, 2. And what we need to do to determine if this ordered pair is a solution is we need to substitute these two values, negative 2 and positive 2, in for x and y. Okay, so I'm actually going to get rid of those marks. We'll do the x in red, we'll do the y in blues. Okay, so the x goes there, the y will go there, and let's just plug in everything and see what we get. So we get 3 times my x value, which is now negative 2, minus my y value, which is positive 2. And we're going to see if that is less than 2. That's the real question. So 3 times negative 2 is negative 6. And then that'll be minus 2. We're going to see if that's less than 2. Negative 6 minus 2, that is negative 8, which is less than 2. This is a true statement. This is true. Okay? Negative 8 is less than 2. So the question says, tell whether the ordered pair is a solution. We can say that yes, negative 2, 2, negative 2, 2 is a solution. Okay, let's try another one here. Number 2, x minus 3y is greater than or equal to 8, and then the ordered pair is going to be 1, negative 1. So my x value goes there, so it's going to be 1, and then my y value, negative 1, so minus 3 times negative 1. We're going to see if that is greater than or equal to 8. So negative 3 times negative 1 right here. Negative times negative is a positive, so that's going to be plus 3. Then we'll have a 1. We're going to see if that's greater than or equal to 8. 1 plus 3, that's obviously 4, greater than or equal to 8. This is a false statement. 4 is not greater than or equal to 8. It is not greater than, it's not equal to. So this is a false statement. False. Okay, right there, that's false. So what we can say then is we can say that 1, negative 1 is not a solution. Does that mean that x minus 3y is greater than or equal to 8 has no solution? No, we're just saying that the ordered pair 1, negative 1 is not a solution. Obviously, there's so many different combinations of x and y that you can come up with that would be solutions, but 1, negative 1 is not one of them. Okay, the main idea of this section is graphing linear inequalities in two variables. Okay, so the graph, this is technically a vocabulary term, graph of a linear inequality in two variables. It's a way to show all solutions of an inequality on a coordinate plane. Okay, so it's kind of going back to chapter 2 where we're graphing, open circle, closed circle, left, right, but now we're expanding it to two variables where now, instead of a number line, now we've got a coordinate plane. Okay, so the steps for graphing linear inequality. Step number 1, graph the boundary line. That's the same rules as if it were just an equal sign. So if we had like y equals, 3x minus 4, that'd be a slope of 3, a y-intercept of negative 4. The rules for graphing the line are not going to change. Get it in slope-intercept form, mark your y-intercept, use your slope to find the second point. What's different with inequalities is if we have a strictly less than or strictly greater than, what that means is you're going to have a dashed line. So your line would look like this. This would be the equivalent of an open circle. Okay, so a less than or greater than, strictly less than or strictly greater than, I'm actually going to erase this and make that look a little better. So less than or greater than corresponds to a dashed line. Okay, if you have that or equal to part, so if you have less than or equal to or greater than or equal to, so remember in a number line, that was a closed circle. With the linear inequalities, with the coordinate plane, now we're going to have what's called a solid line. Okay, and that's just going to look like this. Okay, so if you have the or equal to part, you're going to graph the line just like normal. You don't have to worry about the dashed line. If you do not have the or equal to part, see how this one does and this one does not. If it does not, you're going to have a dashed line. That would be the equivalent of the open circle. Okay, so once we get the boundary line drawn, we're going to do step number 2. We're going to test a point that is not on the line. The point that I would recommend, if possible, is the origin, 0, 0. It makes things very, very easy. Sometimes the origin is on the line, which means we can't use the origin. If the origin is on the line, pick a different point. It doesn't matter which one. I would recommend trying to stay close to the origin, stay close to 0, just because it's smaller numbers, makes it a lot easier to work with. But if you don't want to use 0, 0, you do not have to. You just have to pick a point that is not on the line. For future reference, in the examples here, If I get a point, if 0, 0 is not on the line, I'm going to test that point. If I get one where 0, 0 is on the line, then I'll have to pick a different point, but I'll stay very close to 0, 0. Okay, then step number 3, we need to shade the proper side. This is kind of based on step number 2, and that's what the 2 asterisks there are describing. Okay, so when we test a point, if we get a solution, the side of the line that contains that point is where all of our solutions are going to be. So that's the side we're going to shade. If the point we pick is not a solution, we're going to shade the opposite side. Okay, and I'm going to show you what that looks like here in just a second. Okay, so let's just try here. Let's just try a few. So graph the inequality. So number 1, let's go with y is greater than or equal to -3. Okay, there's no x here, so it's just, so if we think about the line y equals 3 and we did an xy table, we can pick whatever x we want because there's no x in our equation. So we could do like -7, 0, 1, 10, 50, it doesn't matter. Okay, what the equation tells us though is that the y values all have to be 3. Okay, and what this looks like then when you put those points on a graph, all of those points make up a horizontal line. Okay, so the graph of this is still going to be a horizontal line, but now we're just going to have it look slightly different when it's all said and done. So I'm going to erase this stuff here in purple. Okay, we know that y equals 3 is a horizontal line. So what I'm going to do, I'm going to bring in some graph paper, and let's actually graph this thing a little more precisely. So we got our y-axis, we have our x-axis. Now, because we have this or equal to part, that means we're going to have a solid line, and our solid line is going to go through the y value of 3. This is a horizontal line, looks like this. Okay, there's our boundary line. Now we need to do step number 2. Test a point that is not on the line. Prefer 0, 0. 0, 0 is not on the line. We can use 0, 0. Okay, so we're going to test the point 0, 0, and we're going to plug it into this inequality. Okay, we do not have an x in our inequality, so this x value right here doesn't matter. It doesn't matter what the number is. Because we don't have an x in the inequality, the x value doesn't matter. So we're just going to plug in our y value, 0 greater than or equal to 3. That is a false statement. Oh my goodness, I just realized I made a mistake. This is -3, isn't it? Okay. Well, let's try this again. So I'm going to erase this purple line. Guys, I really apologize for this. So -3 is down here. It's still a solid line. There we go. And this needs to be 0 is greater than or equal to -3. That's a huge mistake. I apologize. All right, so 0 greater than or equal to -3. That is a true statement. Okay, this is true. So my point was above the line, in this case above. Okay, when I tested it in, I got a true statement. So this side of the line, the upper side this time, is going to be where all of the solutions are. So I'm just going to shade, and this is what it looks like when you can hand shade. Just kind of sketch in the side of the line that contains all the points. If you want to use a highlighter or a colored pencil or something, feel free. If you just want to use your pencil, you can do that too. That's perfectly fine. Let's try another example here. Number 2. Let's go with -x plus 2y is greater than 2. Okay, so this is in standard form. Our x's and y's are on the same side. So in order to graph this efficiently, let's put this into slope-intercept form first. Okay, so we'll do that in green. I'm going to get the y by itself. To do that, I've first got to get the x to the opposite side. So that's going to leave me with 2y is greater than +x, +2, x plus 2. Then I need to divide both sides by 2. The 2's go away on the left, so I got y is greater than, let's see, x over 2. If I have one pizza and I split it between 2 of us, each of us gets 1/2 of the pizza. So 1/2 x, 2 divided by 2 is 1. If you're going to divide everything, or divide this side by something, you got to divide everything by that number. Okay, so y is greater than 1/2 x plus 1. This is our inequality that we're going to work with. Okay, so let me, we've already got graph paper in. Let me bring in an axis, a coordinate plane. So there's the y-axis. Here's your x-axis. Let's go ahead and graph these. So my y-intercept is 1, so I'm going to make a mark at 1. And then my slope is 1/2, so I'm going to go up 1 and to the right 2. +1 over +2, +1 over +2, up 1, right 2. Instead of going up and to the right, you could also go down and to the left. So down 1, left 2, down 1, left 2, down 1, left 2. That should be plenty of points. Okay, now we need to figure out, is this going to be a solid line or is it going to be a dashed line? Now, if the inequality, this one does not have the or equal to part. It is strictly greater than. If we go back up to our rules, if we have strictly greater than, that's this one, it's going to be a dashed line. Okay, so let me go back to the picture. This is a dashed line. So we're just going to sketch a dashed line through that. Now, a quick way to do that, if you want to make a solid line and then just erase pieces of it, that's a quick way to make a dashed line as well. Okay, so we've got our line in there. Now let's go ahead and test a point. 0, 0, again, is not on the graph, or it's not on the line, so we can use 0, 0. Okay, so I'm going to test 0, 0. And we have a couple of options. We can put it right here, or we can put it right here. It doesn't matter. I'm going to use the top one. I'm going to use the original inequality. Okay, so my x value is 0, so I'm going to have negative 0 plus 2 times 0. We're going to see if that's greater than 2. The opposite of 0 is still 0. That goes away. 2 times 0, that's also 0. That goes away. So I'm left with 0 on the left-hand side, greater than 2. This is not a true statement. This is false. Okay, this is not true. 0 is not greater than 2. So what this means, this point I tested was on the, we can call it the bottom side, or the bottom lower right-hand side of the line. And when I tested that side, I got a false statement, which means all of these points out here, all of these points on this side of the line are going to give me false statements, which means this side of the line, the opposite side of the line, that's where all the true statements are. So when I graph, or when I shade, that's the side of the line I shade in. Okay, you don't need to go very big or very far away from that line, or far away as far as covering a bunch of graph paper. This isn't a whole lot of room. Okay, so if you get a false statement when you test, then you shade the opposite side. If you get a true statement like we did up here, then that's the side of the line you shade. Okay, hopefully that makes sense. If you have any questions, please don't hesitate to ask, and we'll keep working with it.